Hi friends, welcome back. Today we are going to deal with the most important types of relation that we are doing in class plus 2. They are reflexive, transitive and symmetrical relationship. Before we moving on to the main topics, we should understand what is empty relation, what is identity relation, what is universal relation and what is inverse relation. First, let me give a short brief explanations about these four relationships. After that, we can move on to the most important types of relation: reflexive, symmetric and transitive relation. First topic, what is empty relation? From the word itself, it describes us something. It is an empty. So what is empty relation? Empty relationship is nothing but the set, the relation which does not have any value. In other names of empty relationship is what? Null or void. Here this consists nothing. Not at all any relations is will be there. So for example, consider a relation. Consider set A is equal to 1, 2. Given relations are such that ordered pair AB, for that A belongs to A, B belongs to A, such that A plus B is equal to 5. Just have a look at these questions. In Cartesian products is A cross A, whether any elements gives a product, that is A plus B gives 5. Let's just look 1 plus 2. Whether it gives 3? No elements. Here what is relation? When we write these one in roster form, we does not have any at all relations. That we get 0 relations. So this type of relation is described as empty relations. Here it is represented using the letter notification, that is this one 5. This is the empty relation. Next we can move on to the next topic, that is identity relation. Identity, what is that? That everyone know that identity of every person is their reflection or their image. Here same thing, identity relationship means the reflection or the image of an element. For example, if A is the ordered pair, then it's what will be its image? Its image will be A itself. Same way, if B means B itself, C means C itself. So for the clarification or for the better understanding of this relation, let me give you an example. Consider set A is equal to 1, 2, 3. Where relation means what? Relation is of the ordered pair AB such that B belongs to A, where A is equal to B. This is the conditions for the identity relation. Here A should be equal to B. That we already know. Image of the letter will be same itself. Here when the Cartesian products is here, we already know what is a Cartesian products. A cross A. But what is relation? Relationship is a subset of A cross A. Here the which all the elements is, which all the ordered pairs gives the same as that of this one. So R here when we returns in the roster form, what are the elements is 1, 1, 2, 2, 3, 3. These are the ordered pair which give the images. Relation 1, 1, 2, 2, 3, 3. These are the ordered pair which have the exact images. So here the letter notification, the mathematically identity relation is represented using IA. This is the letter notification. So identity element is such that ordered pair AB, for everyone AB belongs to the set A where A is equal to B. This is the letter notification or the set builder form of the identity elements. Next type of relation is universal relation. Universe means what? Everything. So same, the word itself, it describes the relation. So universal relation. For this, let's consider an example. Set A which is equal to 1, 2. What is that? Set A is equal to 1, 2. What is a relations or a set builder form of the universal relationship, which describes that here the number of elements in the Cartesian product, that is A cross A, should be equal to the relation. Number of Cartesian products in the A cross A will be equal to that of in relations. So that means every product on everything will be equal. So then it describes the universal relationship. What is the A cross A? The Cartesian product of A cross A, that is 1, 1, 1, 2, 2, 1 and 2, 2. That's, we already know that. Then what is relationship means? Relation means what? Every elements is, that is every elements relations belongs to the products of Cartesian product. Here it is also a relation. So this is means when it is equal in Cartesian products as well as in relation. So this is called as universal relation. Next we can move on to the next topic, that is inverse relation. What is an inverse relation? Inverse means inverted. Here, what is here? If it is a R means relation, then its inverse means when its power notation that changes to -1. This describes the inverse relation. For this one, let me give an example. Consider a relation R is equal to set A is equal to 1, 2, 3 and B is equal to 4, 5, 6. Then here sometimes we get a relations. I'm just taking a little bit. Okay, I'm not taking every Cartesian products. For that 1, 2, 2, 4, 3, 5. Then likewise 1, 4, like this one I took. So okay, then what will be this inverse and inverse relationship will be what? Here interchange of the ordered pairs, that is interchange of the elements in ordered pair. The first element changes to second element and second elements will be changes to first element. So what will be the inverse here? 1, 2. Then what will be changes here? It changes to 2, 1. So what will be the inverse elements of relation? That is 2, 1, 4, 2, 5, 3, 4, 1. This is the inverse relationship. Inverse means the interchange. Let's move on to the main topic of our class plus 2. That is reflexive relation, symmetric relation, transitive relation, and further after that we should extend our knowledge to equivalence relations. When we recall or when we call these relations reflexive, in order to call the relation reflexive, what is that? It should the same to same elements is the considered an ordered pair. For that, the first element should be equal to that of the second elements. If it show the identity property, then we can say that such relationship are reflexive relation. Here we have already learned what is an identity relations. If this property is shown in the relationship, then we recall these relationships. Consider this relation as reflexive relations. For the more clarifications of these questions, let me give an example. Consider set A 1, 2, 3. Then what will be the Cartesian product of this? We have already explained what is Cartesian products in the previous video programs. It says here what are these? 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. Here which shows the identity properties is this one 1, 1, 2, 2, 3, 3. This ordered pair shows the identity properties. A relation is reflexive if A and ordered pair A which belongs to relation for all that element is belongs to a set A. This is what we recall reflexive relation. Next, let's move on to the next relations, that is symmetric relation, which shows the properties. Symmetric relation is what? When interchanging of the ordered pairs elements is when the first element is interchanged with the second element and second element is interchanged with first element, then such relation is called symmetric relation. A relation which shows the inverse relation properties is, then we recall this as symmetric relations. For the clarification, let me give an example. Consider set A where 1, 2 and B is equal to 2, 1. Then here when we defines as A cross B, we get 1, 2 and 2, 1. Then which element shows this one? First element and second element interchanged elements, then such relation is called symmetric relation. So now let's move on to the third important relation, that is transitive relation. A relation is said to be a transitive when ordered pairs, that is A, B, where first element and the second element of the second set belongs to relationship, then same B and C belongs to relationship, then we say that this element and this element belongs to a relationship. If this three condition is satisfied, we recall that relation as transitive. For example, for a clarification of this, consider set A equal to 1, 2, 3. Then what is a Cartesian product? I just written a little bit of these relations. Okay, Cartesian products, it consists, we have already know, it contains a lot of elements, that is across A. It have lots of elements. Now I just written a little bit a relationship. Here just look here, ordered pair 1, 2. Here just look here, this element and this third here. This is another relationship, another ordered pair in a relationship. Just look at this one here. Just here, this is a first element and this element C. So this also belongs to a relationship. Then we can recall this relation as transitive. This is the three important relation: reflexive relation, symmetric relation and transitive relations. Let's recall what is equivalence relation. A relation is said to be equivalence when a relation shows these three properties, that is reflexive property, that means a property of identity elements; symmetric relation, a property which shows the inverse property; then transitive relation. Then if three relations are satisfied, then we call that relation as equivalence relation. Just have a look at these examples. Now for the more better understanding, let's do a problem. Consider a relation R on a set A equal to 1, 2, 3. Check given relation, that is reflexive, symmetric and transitive, and also verify whether it is an equivalence relation. For example, what is a given set? Set A equal to 1, 2, 3. These are the elements. Then what is the Cartesian products? A cross A consists of these elements: 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. Now just look whether these Cartesian products have reflexive property or the identity elements. Just look here, reflexive. Just look 1, 2, 2, 3, 3. Yes, this element shows the identity properties, that same elements on that next the set B, ordered pair P. When it shows the doublets, we recall that one. We already know that it is a reflexive relations. So what are the examples? Relations, it consists of the elements 1, 1, 2, 2 and 3, 3. So the relation shows relation shows the reflexive property, that is R equal to AA for every A belongs to a relation and A equal to AB where A belongs to relation where A equal to B. It shows a reflexive property. Next, which property we have to apply? Next is symmetry. We have to verify whether the relation shows the symmetric property. Just look at this. Okay, here 1, 2 is there. 2, 1 is also there. Okay, then we can say that 1, 2, 2, 1. 1, 2, 2, 1. Just look this one. Yes, it has an inverse property. So relation R shows the here also 1, 3, 3, 1, 2, 3, 3, 2. 1, 3, 3, 1, 2, 3, 3, 2. These ordered pair shows the inverse relation. That is, relation R shows inverse property. That is, it shows a symmetric. R shows symmetric property. Now just look, any elements in the Cartesian product shows the transitive property. Just look here, 1, 2. Here just look 2, 3. Okay, let me given a relation is there. Given is there the Cartesian product 1, 2, 2, 3, and also one more is a 1, 3. Just look at this here. When we can say it as A and B. Here B and C. Just look, and this is A and C. So what is this? It shows the transitive property. That is, AB belongs to relation. BC also belongs to relation, that which implies as AC also belongs to relation. Here just look, the relation shows the transitive property also. So this relation is also a transitive. R is a transitive. Just look, this Cartesian products A cross A shows both three properties, that is reflexive, symmetric, transitive. So hence we can define these relation as equivalence relation. Hence this relation is equivalence. This relation R is equivalence. This relation R is an equivalence relation, since this relation R shows reflexive, symmetry and transitive property. Just have a look at these questions. If you have any doubts or anything, means please you can comment on our comment boxes. Just have this look and verify the answers. Everything says here relations is R is given on the R as A cross A. Okay, this is the relations here given, and it shows reflexive, symmetric, transitive. I hope you have understood this